We're Group 15 with the Imitation Holographic display, and this video is going to cover more of the detailed aspects of our project. Starting off, our main motivation for this project was just to gain experience working in teams and then coming together to create a product. Initially, we were inspired by the LED fans and displays that are used to create images, and they've been growing in popularity over the years with more and more users working individually and on coding and projects. And so these fans and displays operate using an LED strip that rotates at a very high RPM in order to create an image. Now, while those have been done a lot, we figured that there'd be too much code for us just to base ours off, so we started to go in a different direction. For our project, we wanted to use a display instead of an LED strip. And so we wanted to create an eye-catching rotating display that when rotated at a very high RPM, about 1800 RPM, which is equal to about 30 frames per second, we would be able to see a distinct animation amongst it. However, with that RPM, we would need to make it a safe display, and so our main priorities were achieving the speed, seeing the image, and then closing it in for safety and making sure everything was bolted down. When designing our project, we knew that we were going to split into two teams, and we're going to have an electrical engineering side that would handle the frame design along with interfacing with the motor, and then we were going to have the computer engineering side which would handle the microcontroller along with the display. Starting off with the computer engineering side, we knew that we were going to use an OLED display, and that OLED display used the SSD 1531 driver. Now, this display was compatible with Arduino, and there was a lot of support for it already. And so for our microcontroller, we wanted to pick something that was also compatible with Arduino. We started off with the STEM32 Nucleo controller. However, we ended up switching to an Arduino Mega later on in the project. Luckily for us, the STEM32 and the Arduino had a very similar pin layout along with being compatible with the Arduino IDE, so the switch wasn't that big of a deal. Now, using this display, we knew that it was going to have to draw very fast for rotating at that high speed. So instead of going with an image to display, we wanted to pick like a simple animation. So we made a cube animation based with like a wireframe. That way we wouldn't have to update the whole display, and we were able to draw quick lines that we can draw and erase very quickly. Along with the display, we had the wires to it soldered in order to improve stability. And moving on to the EE side, we wanted to have a secure structure that, while everything is spinning, everyone would be safer around it. So we used the Lexan, which is much stronger than plexiglass and also a lot safer, and it's a lot more shatter resistant. And we had a wooden frame surrounding that. So the Lexan allowed for users to be able to see it from all four faces of the cube, along with having a nice wooden top and base with the wooden four support beams on the corners. Additionally, goes into the motor, which is controlled with an 11-volt sensor. This motor is a drone motor which operates well above 3000 RPM. However, we wanted to keep it on the lower end of its operation because we didn't think that our display would be able to keep up, because this is a very scaled project. Additionally, when we came together, we knew they were going to have to find a way to implement the RPM counter of the system. And so for that, we implemented a Hall sensor with a magnet that is attached to the base of the frame. The Hall sensor would record the amount of time it takes to do 10 revolutions on the Arduino controller, and then it would then calculate the amount of revolutions that it could do in a minute in order to give us our RPM. Once we put the two parts together, we mounted all of the computer engineering parts into the middle on this rotating frame with a 9-volt battery attached to the back. We knew that we were going to have to operate on its own power supply and have that power supply rotating with the device in order to have safety and not have to buy anything to let the wires move freely. So this allowed us to just wire the 9-volt into the VN, which is easily interchangeable on the back, and we were able to supply both our Hall sensor, our Arduino Mega, and also our display with that. As far as performance goes, we were able to see smooth images Our best performance operated about 1200 RPM, and we were started to see a little bit of breakage when testing at different speeds. However, 1200 seemed to be the most consistent with what we wanted. Additionally, we couldn't really get the perspectives to show, which was our biggest weakness, I'd say. We really wanted to be able to see a different angle of perspective, as if you were walking around an object, you'd see a different thing. However, we wanted to accomplish that with just a screen. And so we think that part of the reason is just we needed a live control system. And so having a live control system which would be able to accurately update the RPM as it's spinning, as our project only does it for the first 10 revolutions, we get a consistent RPM. So if the RPM varies after that time, then it could break apart the image. The image is split into 4 segments because there's 4 different animation frames. And so if that RPM changes, then the frames will become off timed pretty much. Additionally, 2 of our strengths were the RPM counter. And we were able to get RPM at a lower bound of around 900 and an upper bound of around 500 after, having the weight of the system and everything like that. So we got the RPM counter working fine, and it's displayed on the OLED display. Additionally, safety-wise, we didn't have any parts fly off or any part of the frame broken or nor the Lexan. The only thing is that it is a little bit off balance, so it has to be weighted down in some way. However, in a realistic setting, we'd have the frame probably stable or weighted down or bolted or screwed in some type of way just to keep it steady. However, safety-wise, we were very impressed with the way it performed. And here we can see some of the tested out images, along with a little bit of attempts at different perspectives. Additionally, we included a color test just to see, different colors and see how well we could separate those while going at a high RPM. And again, it wasn't the performance we hoped for, but it was definitely close to, being where it needs to be. However, with the scope of this class, we just wanted to make a quick prototype that we could see and function just to see if our idea would work. If this project were to be expanded on and scaled more, we could see it being used in malls or any type of advertisements where they need a eye-catching display. As long as it's sealed, it could be scaled up, and that would allow for systems to have faster revolutions or better draw speeds or better displays. As our display is only 128 pixels by 128 pixels, it'd be a little bit hard to see. However, with the right time and work that could be put into this project, it could really be expanded upon into something a bit further.